Quality control is an important aspect of manufacturing process. Suppose a local company manufactures soda dispensing machines that fill bottles with 600 milliliters of soda. Over time, the dispensing machines can become less precise. That is, older machines may dispense too much or too little soda into the bottles. When something becomes less precise, we say that it has lost its precision. When it happens, the machine requires an adjustment. In this case, a soda dispensing machine will need adjustment if the mean amount of soda, okay, keyword everybody, mean amount of soda dispensed is different than 600. So these two are keywords for now. The owner of soda dispensing machine believes that her machine has lost precision. She measures the amount of soda dispensed at 8 random times throughout the day. The 8 amounts of soda her machine dispensed during the day are listed below: 600.15, 599.92, 599.85, 599.92, 599.81, 600.14, 600.04, and 599.98. At 5% level of significance, is there enough evidence to conclude that this machine needs an adjustment? Research has indicated that the amounts of soda dispensed from the machine are approximately normal in their distribution. What is the null hypothesis? Guys, take a look. We have the keyword different. It's not the same, not equal to, different from. It means that your alternative hypothesis is given. Mu is not K. K is 600. So the null hypothesis says, hey, mu is K, and the alternative hypothesis says mu is not 600. So in this question, is different, it means that the alternative hypothesis is given to you. You can easily write down the null yourself. Mu is 600. Now, we want to make a decision about null hypothesis. So we need to find the average. If you enter these data into your calculator and calculate the average, it's going to be 599.98. The standard deviation is 0.126. Pay attention in the question. Round your answer to 3 decimal places. So that's why you have 0.126. Why it is important for us? Well, now that we have all the information about the sample, we can go ahead and calculate T. Recall that when sigma is missing, T, or standardized test statistic, is x bar minus mu divided by S over square root of n. It follows a T distribution. Well, okay, T is x bar minus mu over S over square root of n, or 599.98 that we used from sample, minus 600, which is our population mean, mu, divided by S, which is 0.126 over square root of n. Remember that at 8 different times, random times. If you do the calculation, your T becomes negative 0.45. Why it is important for us? Now we can use T to find p-value. How do we do that? Well, this is just the area below the T distribution. Remember that. First of all, you have a two-tailed test because your alternative hypothesis says, hey, mu is not the same as 600. So since mu is not the same as 600, it means that it's either less than or more than. So this is your alternative hypothesis in this question. H sub A say that mu is not 600. That's how you end up with a two-tailed test. For a t-distribution, the degrees of freedom, as you remember, is n minus 1. N is 8. So 8 minus 1 is equal to 7. So again, this is equal to following the formula n minus 1. If you use your calculator or the t-distribution, the area to the left-hand side of your negative 0.45 with degrees of freedom 7 is going to be 0.0333. But since you have a two-tailed test, you have to multiply that by 2. So p-value is 0.666 or 0.67 or 67%. Now, if you compare p-value and alpha, since p-value is more than alpha, you're going to reject it. Why? Because p-value is 67% and the level of significance is 5%. That's a huge difference. 67% is more than 5%. So you're going to say that, hey, we're going to reject the null hypothesis. The null hypothesis saying that, hey, this was my null, that the mean is 600. So we're going to reject this. It means that the machine needs precision